Good evening, everyone. Thanks so much for coming to my talk on Solady. So today I'm going to tell you how to do some gas optimization with Solady. And hopefully it won't be too complicated. Okay, so first thing, you can visit the GitHub repo at solady.org, or you can ask me any questions at my Twitter or X. Optimizoor. Okay. So yeah, remember the URL. I've bought this domain, so you don't need to remember the entire GitHub. Okay. So first question is like, why do we even want to make a library? Like, there's OpenZeppelin, there's Soulmate. So the first point is quite obvious. Like, we want to save gas. Is who doesn't want to pay cheaper price for the same end result? And because we save so much gas, it enables us to unlock new cooler features, which I will show later. And because it allows us so much flexibility, we can craft our library APIs to become more beautiful, like more sleek. So some testimonials. One of my friends, zeronodes.eth, he said, went down the Solady code base this morning, some incredible gems in the YouTube leaps. Sorting an array in place, wow. Incredible that vectorized low-level U code makes Solidity feel like a high-level language. Yeah, so the thing about Solidity is that it has a lot of missing features out of the box, like sorting or maybe doing some math, like you want to compute the square root or something. It doesn't have all this out of the box. You have to implement it. So another very prolific developer, Paul Arberg, he's the author of PRB Math, one of the most widely used math libraries in DeFi. So he said he skimmed through the library and he said it's the most impressive Solidity repo I've ever seen. Okay. Yeah. One thing is, regardless of how bullish you feel, please don't buy any NFTs. Okay, nothing in this talk is financial advice, please. Okay. So some philosophy. Okay, I know that in the space there's Viper, there is Half, there is many languages. So why choose Solidity? So to quote the famous developer Chris Degner, the inventor of Swift, one of his interviews with I think Lex Friedman, he said, so the goal of a good language is to allow people to design good libraries. So Solidity allows inheritance and allows low-level SMP. And with these two, we can work some magic. Another very famous guy, Todd Propstein, yeah, he said that compounder optimization performance don't increase that fast. Approximately 2 times it only doubles every 18 years. So like everybody complains that Solidity is unoptimized, but why not just code the optimal code right away with all the tools it can provide? So that's why we code Solady. Okay, I know a lot of people are going to L2s right now. Like L2s are super cheap and it makes a lot of business viable, like Friendtech. Like Friendtech cannot run on L1, definitely. So one thing about L2 is that the transaction costs comprise mostly of core data. So you can like store a lot of stuff on L2, but the amount of money you pay for the storage is like orders of magnitude lesser than the amount of money you pay for core data. So Solady is still relevant in the L2 context because it has core data compression. And it does it in a very out-of-the-box, plug-and-play way. So there's a Solidity library. You just include these lines into your contract. And there's a JS library with TypeScript definitions. You just call one line, zip core data compress, CD compress, and you compress the core data with some runtime encoding scheme. You don't need to understand what is it. But it just makes your, so basically it just reduce your core data cost on L2 like about 50% for typical like Uniswap kind of core data. Okay. So there's also other features like you can do FLZ decompress. So FLZ is fast LZ. It's a variant of the LZ77 algorithm. So if you want to store like big chunks of text on chain, because L2 they make it cheaper to store, so it's viable. You can consider using this function because it allows you to store text in compressed form, and when people read it, you decompress the text on the fly. Yeah. And it allows you to store more stuff inside with the same amount of stuff, with the same amount of gas. Yeah. So there are also other things like JSON parser lib. I think it's the only viable JSON parser lib in the whole Solidity space. So you can combine this with other things like base64 lib string to do fancy higher level stuff like JWT, which is taken for granted in most other programming languages. I think this code is not very secure, but so if you, please don't copy and paste anything. Okay. So there's also like lib sort. So what is sorting good for on-chain? Like, okay, first, let's say you have a list of addresses. After you sort, you can unify it. You can ensure that it's an array of unique addresses. And then you can do set operations once you have ensured that it's unique. So lib sort has all this fancy stuff to allow you to do that. And it also helps you do testing easier. You know, in Foundry, you can pass in an array of addresses to do fast testing. And this array, often it contains duplicates. So if you use lib sort, you can remove the duplicates with just 2 lines of code. Sort and unify sorted. So it makes like Foundry much more easy to use. Yes, and also another very common util that you might find useful is libmap. So in Solidity, most people will use a mapping like mapping uint256 to uint256. But what if the value is like a small number, like a timestamp? So timestamps, I think 40 bits are enough to last beyond our lifetimes. So you can use a uint40 map. So what it allows you to do is, instead of using 256 bits to store one number, you can use 256 bits to store 6 different numbers. So you can save gas. And it's like, you just have to include it, then yeah, the API is simple. So there are drop-in replacement for ECDSA, signature checker lib, Merkle proof lib. So there's OpenZeppelin. If you just change the thing to Solady, you get like thousands of gas in savings. And ERC-1967 factory is like, how to say? I'm not a fan of upgradable contracts, but some people like it, so I just include it. So what it does is that it allows you to deploy upgradable contracts in a super efficient and super clean way. Yeah, okay, these libraries, okay, all the libraries here except Red Battery Lib have been audited by SpearBit. So you can feel more safe to use it. Okay, lib clone is like, yeah, clone. So Red Battery is, if you want to do on-chain order books, you might want to consider Red Battery. So it maintains a sorted sequence of stuff on-chain. Okay, talking about code base, I kept the code as minimal as possible, minimal inheritance, minimal dependencies. So I know in OpenZeppelin, one file refers to another file, refers to another file. Like, it's crazy. So in Solady, the hierarchy is very flat. One file might only refer to one, at most one file at max. But most files, like 90% of the files, don't refer to any other files, don't import even any other files. So it also doubles as a very great learning resource for inline assembly, or what we call U. Because I know official documentation is not that detailed. It doesn't teach you all the tricks and stuff. So most people, after you read the official documentation, they come to Solady to pick up some tricks. So talking about tricks, how we make Solady efficient. How we lower the runtime gas in Solady. First thing is that for the math libraries, okay, pretty much all the functions in this fixed point math are the most optimal implementations known to mankind. Yeah, if you can find something, please contribute, please open a PR. We want to maintain the best implementations. So like kuberoot, basically what we have here is the log tool to find the initial gas, initial estimate before we do the so-called Babylonian method. And this magic line here, I don't know what it actually means, but somehow after I fast test it, it works. I fast test the whole day, yeah. Okay, then here is another nice function called log10. I think some DeFi protocols use it. I'm not exactly sure how they use it. Okay, but anyway, okay, OpenZeppelin has it, but ours is a bit more efficient. We use some tricks. I don't know how to explain it, but it's like I plug the numbers into Z3 and it says it's equivalent. So I think we are safe. Yeah, so Z3 says that it's formally proven that it's equivalent to the original implementation. So yeah. We have, okay, this one, I think you can't see the code here because it's too small. So this is Merkle-proof verified core data, which is also available in OpenZeppelin. But here we use some bitwise tricks to reduce branching, make like it more lightweight. Then here is safe transfer from to safe transfer ERC20s. Okay, please read the next spec when you use it. I think it's too small, the code down here, but if you decide to use it, please read the next spec. And it does all those cleaning of the upper bits and all those fancy stuff. Okay, and also because we have inline assembly, we can do stuff that are not viable in Solidity, like regular Solidity. So when, like, transferring if, it sounds very simple, but what if, for example, you have a noun style option? So what I mean by noun style option is that when the new bid comes in, the old bidder gets the if refunded. So what if the old bidder is some malicious gas burning contract or some contract that doesn't have the fallback function? Then your contract will be screwed. So what people do normally is that they wrap the if and then they send the wrap if. It's a legit solution, but I don't really like it because wrap if is like, you know, wrap if contract on different L2s, there are different address. It's not the same address on every L2. So it makes your coding and deployment very difficult. So instead, you just import Solady, use this function, and if the address you want to send if is a nasty contract or something, you will just abuse the self-destruct instruction to force send the if. So you don't need to hardcode any wrap if address down here. Okay, another advantage is that Solady makes your bytecode smaller. And why is that good? Yes, let's guess. But on L2 context, okay, there is a popular standard called Diamond Standard. And the argument for the Diamond Standard is that because you want to fit everything into one contract and there's a limit called the Spurious Dragon limit. But my argument is that if CPOT can fit in one contract, you have no excuse. So if you use Solady, you will likely not run into this limit. Yeah, it makes your audit cost cheaper. If not, you have to pay more. Diamond pricing. Yeah. So Solady is also like future-proof. Our gas optimization is not just for now. It's for the future. Like in the future, Vitalik proposed this thing called the Worker EIP. The gist of it is that in the future, maybe reading consecutive storage slots might be cheaper than reading random storage slots. So we use some assembly to do custom mappings to optimize for the 2033 gas meta. A decade later. And also the contract has what we call storage heat shrinking. That means, you know, an address has 160 bits. So the 96 bits left over is kind of wasted. So we expose internal functions for you to store stuff inside those remaining 96 bits. Okay, another good advantage, or some people call it disadvantage, is that Solady is compatible with both regular contracts and proxies. What this means is that our constructors don't take in arguments. Instead, we have initializers that you have to call. Like, if you use ownable in OpenZeppelin, you don't need to initialize the owner, but in Solady, we insist that you do that because we don't want to maintain a separate repo for upgradable contracts. So how OpenZeppelin does it is that they have an original repo and they have an upgradable repo. And every time they put stuff to an original repo, a transpiler will transpile the stuff into an upgradable form for the upgradable repo. And I think that this is very hard to maintain. So in Solady, we just insist that everyone calls the initialize functions properly. And also, we don't take in the name and symbol for the constructor. We just tell people to override it and return a constant. This helps save gas, also leads to smaller bytecode. So it's like win-win, but people have to read the next spec and know how to use it. So security and correctness of Solady. Because it's foundry-based, we use fast tests for almost everything. Some math functions are formally verified. Some are just fast tested for many hours. So we have audits. Note that not everything is audited. So the most important parts are audited. So recently we have the audit by Spearbit. I think the report is coming out very soon. I have the preprint. If you're impatient, you can DM me. I can send you. So we have also audits by Epi and RockawayX, which is a VC in the Europe region, and an independent contractor called Sheng. Okay, but nevertheless, please read the next spec. I will make documentation soon, hopefully. Okay, and test your code. Okay, so why test with your code? It's because you know, like sometimes the code alone it is safe, but if you combine the code with something else, the interaction might cause some trouble. Although I try my best to make sure Solady is safe with all kinds of code, but you never know. So yes, please test your code. Yeah, and also something is like some files they use precompile, like precompile 4. So precompile 4 is an identity precompile. It's not available on the chains. So if you try to deploy it on ZK Sting, your contract might break. Yeah, so please test. Okay, so to do more features and documentation. So features 66514337. Yeah. Okay, so the takeaway is visit this website. Yes. Okay, any questions?
So how do you think it will interfere with the compression algorithm of some L2, like for example, optimistic rollup base? So you know, like they already have some compression for the coding.
Okay, right now, I asked the OP devs. They told me that although they do compression on their side, the savings are not passed to users yet. So it doesn't hurt to like include it.
I add a question. So why is it that some of the tokens are globally verified while others are not? Is there a reason besides the source?
First thing is that it's very difficult to code, like to write tests to formally verify everything. That's one thing. And some functions, there's a prover called Z3 and a prover called Hamo. So Hamos also use Z3. So the thing is that all these formal verifiers take super long, and sometimes they crash. Like some algorithms, they are not capable of verifying. So we just fast.
I have a question, which will be the last question. Sorry. So, for example, self-destruct is gonna be removed soon. So, yeah, how do you make sure Solady keeps up with the spec changes? Is it a manual process, or
Okay.
do you just do it when something breaks? Or?
So before we decide to even include the self-destruct, I asked about to make sure that the EIP won't screw things up even in the future. So in the future, what they might do is they still will make the self-destruct opcode send the if, but the contract won't disappear. So it still works in this sense.
Thank you.